Welcome to the Global Big Data Conference webinar. So Global Big Data Conference webinar is hosting today on data wrangling. We will discuss what is data wrangling, why data wrangling, how to do data wrangling. I'm Prasad Buddhavarapu. I'm going to be the moderator for today's webinar on behalf of Global Big Data Conference. I'm a data scientist at Cisco Systems, work as part of Analytics Incubation Lab. I have a PhD from University of Texas at Austin. Now let me introduce our today's webinar speaker, Ashwini Kuntamukkala. Ashwini is Enterprise Software Architect at Vizient Inc. He is a leader in the healthcare and supply chain industries to help deliver exceptional, cost-effective patient care at the point of care delivery. His current area of focus is to help enterprises succeed in their big data and cloud initiatives. He evangelizes scalable enterprise architecture, reference implementations, effective data and API strategies, tools and vendor selection, training and mentoring. He's also an avid blogger, published author, speaker, and relishes taking on challenges, high-impact ID projects. Today, he will be sharing his insights on this very exciting and dynamic industry of data preparation called data wrangling. Before handing over to Ashwini, I'd like to make a few announcements quickly. We have an upcoming Big Data Bootcamp at Dallas from May 13th to 15th. This is starting this coming Friday, next weekend, hosted by Global Big Data Conference. We have several hands-on workshops on machine learning with Spark, R, Python, deep learning with TensorFlow, Solar Search, NoSQL databases such as Cassandra, microservices, and several guest speakers discussing real-world use cases of the big data tools. We also have similar big data bootcamps upcoming at Boston, Tampa, Florida. And we also have a 4th annual Global Big Data Conference, which is an annual event. It's a huge conference at Santa Clara from August 30th to September 1st. I would recommend to see Global Big Data Conference website for details on the agendas and everything. So I'll be posting the details in the chat window. So here is the agenda for today. Ashwini will be talking for about 30 minutes, and we will leave some time for questions. We already have some questions received before the webinar. We're going to be answering all of that. Please keep posting the questions on chat window throughout the session. All the questions will be answered towards the end of the talk, depending on the time, of course. Without any further ado, let me hand it over to Ashwini. Let's welcome Ashwini. Ashwini, thank you for your time. Please proceed with the presentation.
Thank you. Thanks a lot. I appreciate you doing that, and especially for the warm introduction. So anyway, I would like to definitely jump right in. I know that this is a Mother's Day weekend. I'm sure everybody has got a lot of family obligations, so I really appreciate all of you guys, especially the attendees and you guys taking time to arrange this conference webinar, primarily as a precursor to the hands-on session on data preparation that I will be doing at the Big Data Bootcamp on May 14th. So my session is on Saturday for about 2.5 to 3 hours. So this is kind of setting the stage for that, and what I would like to talk about is the topic of data wrangling, right? And I'm sure I'll talk about what it is, how it works, and of course, most importantly, why is it that all of a sudden there is a huge influx of tools, and people are talking about this chapter. There is a lot of startups in this field of data preparation, and what has changed recently that makes this a very exciting field to watch out for. Okay, so I'm sure that all of us work in companies where our intention is to make good decisions better, faster, cheaper. That's our motto even at Vizient, is to make quality decisions to have better business outcomes. So many people look at different graphs. Let's say you are a reseller of healthcare commodities, and you're looking at what products sell the best in certain areas, and you make a nice little pretty graph. You make some business insights and use tools such as Tableau, MicroStrategy, and all these data visualization tools. Come up with some great insights, do some great marketing campaign, and then of course your goal is to dance all the way to the bank, right? However, that is in many cases doesn't pan out the way people tend to look at a very a naive example. Okay, so our intention here is to find out the insight that we are generating from the data. Is that accurate? Is that how accurate is it? And so many times what happens is that we've got a vicious cycle in most enterprises. A lot of companies today are struggling with this, especially with the advent of high availability of storage space. It's become cheaper. Compute is available at pretty much at fingertips. So the cost of storage has gone down. People are able to gather a lot more data. Companies are able to gather a lot more data. So what's happening is that we've got this vicious cycle of bad data that is not it's not quality, it's not been cleansed properly, it's not been prepped properly, and we've got multiple sources of truth. The same content, if you ask the same question across different parts of the organization, chances are you'll get different reports, different stats, which leads to obviously incorrect analysis, not only on your part, but also your customers. And eventually, of course, you end up making some wrong decisions and have some poor outcomes. So that is exactly where what I'm going to talk about here. It's kind of setting the stage for data quality. So data quality is an immense topic in itself, right? And according to Gartner, I'm sure many of you guys in the industry follow Gartner reports. Gartner is an eminent American research and advisory firm, especially for IT-related insights. Again, it's been founded since 1979, so they've got a ton of experience, ton of white papers. So according to them, they've claimed that by 2017, even 33% of global companies will have data challenges, quality challenges, and especially in today's day and age, that doesn't sound like a good stat, because it costs companies a lot of money, especially the U.S. economy. It costs a lot of money because of these bad decisions driven by data quality. And there's a nice little cartoon I drew up here that talks about, is this data valid? Many times you make yourself ask yourself that question. Somebody says, multiply by 2 and join with other data set. And that leads me to Darrell Huff's statement, which is a very prominent writer who wrote a book on statistics. He wrote a book on how to lie with statistics in 1954. He said that if you torture the data long enough, it will confess to about anything. Okay, so it's a funny quote, but it kind of underlies the challenges that people face in order to make good decisions. So, and especially in today's world, there is a whole topic of customer 360. People are not only looking at their transactional system, which is finance data perhaps, but they're also looking at profiling. Now, when you look at profiling, you've got a lot of different data sources. You've got emails, you've got APIs nowadays, you've got social media posts of Google Plus and Facebook and Twitter feeds. You've got professionals putting their profiles on LinkedIn, a lot of customer data. Many small to medium businesses have it in Salesforce. Then, of course, if you're a vendor, you've got a lot of your product catalogs that might be in a PDF format. And if you're a small to medium business and a lot of your data analysts are fairly new in the industry, they might be using Excel because that's what they grew up with Excel and spreadsheet and pivot tables. Everybody has their own Access database, so to say. So essentially what I'm saying is that data has a habit of replicating itself across all these different form factors. And guess what happens is that now you're wondering, I've got a story to tell, problem to solve, but how do I get value from all the data that's out there that I can get my hands on? Okay, and one of the important things is authenticity of the data. You've got to make sure that the data you're collecting is authentic as well. So how do you convert your noise to the signal off of which you can make quality decisions? So that is where kind of set the stage for data wrangling. So data wrangling essentially is a process of transforming raw data sets in whatever form it is in into data that can be analyzed, and so that you can eventually generate valid actionable insights. Now this is not a one person job, right? Maybe you're part of the data preparation team, and then eventually you'll create some data sets, and that will be handed off to someone who's into a little bit more into stats and math and storytelling, a little bit more of a data scientist role. So this is more of a precursor to a data scientist. As I say, data scientists spend about 80% of their time preparing data. Well, that may not be true because of the fact the way the the advancements in the tools, like you'll see today, the tools are so rich now that you don't have to spend too much time doing what you did earlier if you're a data scientist. So it's also known as data preparation, data pre-processing, cleansing, scrubbing, munging, transformation, and like one of my colleagues at Vizient, Ryan, he says that data fold, spindle, and mutilate. So all of these are different names of essentially the same concept called data wrangling. So what are the different steps? So for instance, now let's take into the consideration of, let's say you're onboarded with, okay, I understand what data wrangling is, but how do I get started? What is the typical workflow of a data wrangler? So what it is simple. Okay, it's a very iterative process. It kind of comes along common sense, right? So you ingest all kinds of data. You have web scraping tools, you got PDFs, you got APIs, like I said earlier, you got Excel spreadsheets, CSVs, TSVs. So you obtain all kinds of data, whatever you can, legally of course, and you try to understand the data. Typically you'll probably eyeball it, visualize it, do some kind of analysis on the data. And then of course you want to transform, because transformation step is where you need to have a little bit domain knowledge, right? You need to understand what it is, the kind of data you're looking at, and then of course what form do you want the data. Typically you want to have everything in a rectangle shape, right? Records and columns. And eventually I'll talk about why every table structure is not the same. That will come along in a later slide. So, but we'll talk about transformation. So transforming your data into form that you understand, and you can unleash a lot of your analytic tools on Tableau and stuff like that. You can unleash them on the rich curated data set. But of course, after transformation, many times one data set by itself doesn't tell the whole story. So you have got your streaming data coming in from social media feed, web logs, perhaps, and then you want to tie that into the customer's transactional history that might be in a data source somewhere in your data warehouse. So you want to augment your data sets. And of course, you want to shape it up in a form that can be consumed, and then eventually you want to share it, because if that data comes to you and then doesn't go anywhere further, then of course you are not able to gain much value. And there's a whole concept now, or maybe a whole initiative that companies are doing, is to call democratize access to the data. That means data is not somebody's proprietary only in few teams, but in fact the more data is easily accessible to a large set of employees. Typically you'll have more people looking at data from different points of view, and perhaps you have very innovative ideas that will come through from different places in the company. Okay, so sharing is a very important concept there. So essentially what I'm trying to get to is data is the key, but storytelling is the king. But however, before you get to the storytelling, we need to get the data right. So that's where data wrangling is. So quote by John Tukey. John Tukey, of course, a very famous American mathematician. He says that an approximate answer to the right problem is worth a good deal than exact answer to an approximate problem. I think that's what we're trying to get to, is try to shape up our problem very well. Okay. So let's take an example. So for instance, I'll take a simple example, kind of give you a visual understanding, because I learn everything mostly visually. So what does it mean? So let's say you've got a PDF file, typical invoice, right? I'm sure many of you guys have received it from the vendors you purchase products from. Now what does it mean? You got a whole bunch of PDFs with invoices, and you're trying to reconcile that into certain report. So I used a tool called Data Watch Monarch Complete, and it's not a free tool, but it does a good job with what it does. And I was able to convert this PDF file into a nice rectangle shape. Now I'll talk about how I did that. However, that's the intent of it, right? Because PDF itself, you can't unleash SQL on it. You can't unleash R on it. You can't unleash any analytical tools on a PDF file. You have to convert it into a tabular form on which you can unleash. So this process of conversion is what I'm trying to get to, is a facet of data wrangling. Let's take another example. Let's say you've got an image, right? These days there's a lot of hype about image recognition, pattern matching, handwriting recognition, speech recognition. So these are all different aspects of wrangling. So let's assume that we've got a picture here. How's it going? This is pretty interesting. Data wrangling. I used a tool called TextRack by Python. It's written in Python and uses a library called Tesseract OCR, and I was able to get the text. I'm sure the handwriting one didn't work out well, but I was able to get the text out. How's it going? This is pretty interesting, isn't it? So what happened here is that now I can take this text, index it, and then perhaps match it to this image, right? So an example. So the important thing here is for you to understand your data. Okay, and for instance, as human beings, we talk in terms of unstructured content. We say, okay, a typical conversation, right? Hey, my Chevy 8 is running low on fuel. Didn't I just fill it up yesterday, right? So this is what is unstructured conversation. A machine cannot understand it. A machine can understand, of course, you might argue that, okay, the natural language toolkit, you can understand this to a point, but of course, at the end of the day, it's converting this into a name-value pair. A combination of name-value pair gives it a context, right? So owner is Ashwin, vehicle Chevy, type is a gas, fuel level 5% based upon some indicator here, engine is V8, last fill day before yesterday whenever I made this PowerPoint, right? Another example, that's called a structured example. Another example is this string. For instance, you might say, what does this blurb of text mean? I don't know if you guys can decipher this. You got DALDFWSFOE. However, if you put the space in the right place, it becomes a list of airports. I'm sure many of you guys who are traveling will be traveling this weekend through one of these airports. Dallas Love Field Airport, DFW, SFO. So what happened here is that the text by itself did not make any sense, but the moment you parse it in a fashion that makes sense to you, right? So that's the intent of it. So other thing is once you get your data, you look at your data, you understand it a little bit. Of course, you also want to identify any outliers. Now, outliers is a topic in itself. People do PhDs in outliers, and that's what makes your data very, very interesting. So for instance, I give you this random set of numbers, right? What does it mean? 75, 80, 65, at the end you got 110. Without the context, these numbers don't mean much. Maybe you can mean, you can find the median, you can find the mode, you can do some basic math on it, but it doesn't mean much to you. However, if I told you these are lifetimes of certain individuals with certain race, certain ethnicity, certain background, certain control group or treatment group, now all of a sudden your mind goes to work and say, man, this makes sense. This is valuable data based upon what I just know about the content. So if I draw a box plot, I can put the minimum, maximum, I can put my quartile 1, quartile 3, and then I can see this is an outlier right here. Somebody lived up to 110. Now that is of interest. Is that a real data? Is it fictitious? Somebody entered it wrong perhaps. It was supposed to be 10. Somebody fat fingered it to be 110. Or maybe it is really 110. So that is where you would get into a little bit more understanding of looking at your data set and then trying to figure out outliers. Another example is missing values. Missing values is also very key. See here, so many times people fill whatever form they need on online. There's always a bias there. There could be a whole bunch of data that you've gotten based upon the number of visitors on your site on the days of the month, but then there is 11th and 12th of the month and 5th, 16th of the month, there is no data. What does it mean? Maybe the server crashed perhaps? So you're missing completely at random there. And then of course you might have data that might look like this, a comma separated file, somebody hand entered a whole bunch of data. As you can see, this data doesn't map correctly. The customer name followed by the address line 1 didn't have the comma separator. So the customer name included the name as well as the address line 1. As a result, everything else queued and the zip is missing. So now the state has invalid content, city has invalid content. So what I'm saying is that you've got to make sure that as a data wrangler, you're looking out for issues like this. Okay. Missing values due to data ingestion. And then of course, finally, I'm sure many of you guys have been to a doctor's office. They give you a nice little form to fill out, and depending on your gender, you'll fill certain form aspects that are relevant to you. So on the same form, you got women's health and you got men's health. Chances are nobody's going to fill both together. So missing data because of inapplicability. So something for you to consider when you look at the data, right? So what types of data do you have? You got qualitative, you got subjective. A simple example I'll give you. You got a bunch of balloons here. Okay, a simple conversation would be, hey, so many balloons here. Is it for my birthday? The air pressure is 15 psi. We are 139 meters over sea level. What does it mean? So if you look at it, the colors of the balloon, right? That's categorical variable. You got oranges, you got yellow, green, red, purple, right? Those are categorical variables. Number of variables, you got about 6. That's a discrete variable. You got the air pressure. That would be a continuous variable because 15.1, 15.11, there's not really a integer value there. So that could be an example of continuous variable, and then you might say, oh, these are really good balloons. Now good is subjective. That is where it becomes qualitative. So keep in mind that when you're looking at your data, you're looking at these different angles, different filters, and then of course important thing as a data wrangler you need to ask yourself is you need to make sure that the data is credible. It's credible, complete, verifiable, accurate. I'll not go through the whole list here, running out of time, but you can see that this is the intent, is that you want to make sure before you start analyzing something, you want to see if it is even credible, right? If it is not a credible source, don't bother. And provenance is a great word. It's talked about the lineage of your data. There's a source provenance and there's the transformation provenance. You want to make sure that you are aware where the data has come from and how has it changed. And there are a lot of tools nowadays that tell you the entire history of how the data set has morphed into the current form from the original. So now let's look at, like I was saying earlier, all the table structures are not the same, right? All the rectangle tables are not the same. What does it mean? Most of us are very familiar with this. I'm sure all of you guys are very familiar with this type of data structure. You got school, years, and rate of admission, or maybe number of students enrolled. What does it mean? So you got year spread across 3 columns. So this is a row, and that's a column. I think everybody knows this one. However, this is not a data that is easily analyzable. Okay, the way you would want it to look like is something like this, wherein your variable, like they say, there's a very good example by Hadley Wickham. He is one of the chief scientists at RStudio, and he's got a paper on, if you click this link, you'll see that link. It'll take you to the white paper, the research paper. He talks about 5 different problems people have when dealing with rectangular data forms, and he says that this one is when your columns are essentially multiple, the same variable is split across multiple columns. So one observation here and variable. So if you look at it now, your variable year is in the same column. Makes it much easier for you to analyze this data set. Another problem here that you'll face with tidy data is when your multiple variables are mashed up in a single column. So let's say you got a bunch of movies that are released and categorized as comedy, thriller in Q1 of the year, Q2, Q3, and then these are the number of hits, the number of movies that succeeded at box office, right, in 2014. And those are going random. This is just figment of my imagination here. Okay, I've just taken an example. So if you see, now how would you find the total number of comedies in 2014 that really did well? Okay, that it's not easy to form because you've got to split comedy Q1, comedy Q2, comedy Q3. So what you want to do is split it up across this way: category, quarter, year, number of hits. So now this makes it very easy for you to analyze. Of course, if you want to find the total number of movies, or what is the percentage of comedy movies that hit, it's easy because now on the right hand side you can add another column that is total number of movies, and you can calculate your percentages, which is very unlikely possible in the first one. Then of course another example of this is when you have multiple variables that are stored in one column. Okay, so you got rating, which is good and excellent. This is different variables, right? The rating of the movie, and then the year or the quarter. They're all spread across. So it's very hard for you to analyze. However, if you made it like this, wherein you have category, quarter, and then this becomes a variable by itself, excellent is a rating and good is a rating. Now you can calculate fairly easily different types of queries on this. So what I'm trying to get to is tidy data is something where each observation unit is complete and each variable belongs in only one column. Okay, makes it much easier for you to analyze. Fourth one is, let's assume that you've got multiple types of table data in a table. So for instance, you've got invoice data that you flattened out. So you got Jim Jones, he bought 2 items, a hammer and a screwdriver on the same invoice, right? And he bought 1 quantity, 2, and whatever, all these things. But then you got repeating data sets. You got Jim Jones content is repeated, and same is the case with Mike Ezekiel. Okay, so what would most people do is they'll normalize this data into 2 tables. One is invoice data and one is line item details, and they'll join by the invoice number, right? So that's typically what you do with one of these problems. And then of course the final one that I'll talk about is, let's say you got this is very common again. You will have truncated data. You'll have each file containing a certain time of data sets. So for instance, you've got a movie detail here, category, quarter, and year, and you might have multiple files that have the same detail but across different time series data. So time series data split across multiple files. Now you've got to aggregate all of it in one nice table that you can run your analytics on. Okay, so these are like the 5 different common problems that you will see among data, even rectangle data that you will ingest will have some of these problems. Okay, of course each of these forms have their own way of the reason why you do some of those other forms is because they lend themselves for easy and intuitive understanding, because it makes it much easier for you to consume visually. However, for analysis or using SQL like tools, a rectangle form like the way tidy data makes it much easier. Okay, now you might be asking yourself, how would you do all this, right? That's where the difference between schema on design and schema on read. A lot of people are aware of RDBMSs and ETLs, but they are schema on design, where you have to know the structure of your tables, add a column, drop a column. There's a whole process around it. But we're talking about schema on read, very dynamic, very fluid, in-memory kind of situation, without have formal create table, alter table, drop column, none of those encumbrances when it comes to data wrangling. So what choices do you have? I've got several choices. In fact, on a popular open source, you got R and RStudio. It's a fantastic, in fact, the data wrangling exercises I'll be talking about are built on R and RStudio. A fantastic experience that I've had. Of course, you also have IPython, which is a notebook on top of Python, and Pandas, which is a library that people have created to do all the things. So pretty much R and Pandas are pretty much on equal footing, so to say, at this point. But of course, Python is a little bit more dynamic when you can even create websites using Python. Somebody may argue you could do that with R, but I've not seen anyone yet do that. Of course, there's also a tool by Google called OpenRefine. It's a fantastic tool for lightweight data wrangling. And you got different tools such as Beautiful Soup. It's a Python library for scraping websites. And if you're really keen on this, right, my recommendation is go to School of Data and open Foundation Labs. Fantastic websites. You'd get a lot of content, a lot of free tools, recipes on how to do data wrangling. There are a lot of commercial vendors. In fact, I've had the fortune of working with many of these vendors on different projects, especially the one that the hands-on exercise that I'll be doing is I collaborated with many of them to see what capabilities are, and I'll be talking about the differences between each of these tools, especially if you're a person who's going to make a choice when it comes to what tool to purchase for your team. That'll be a very good insight for you. So I'll be differentiating DataMirror, Trifactor, Tamr, platform. Some of these companies had excellent customer service. Some of them did not. I will not share who did not to protect the innocent, protect the guilty. However, all fantastic products that you have access to. So what we'll talk about on May 14th is I'll be doing a lot of hands-on exercises. I'll be taking some different types of data sets. I'm doing a lot of wrangling using these examples, and my intent is to share this after the event. Okay, so you definitely want to be there so you can get a lot of hands-on experience when it comes to using R, Open Refine, and Trifactor Wrangler. So the problem that we'll try to solve, or we'll try to ingest all kinds of data, especially CSV, PDF, JSON, web scraping. We'll do some exploration of data using graphing tools. We'll also do some missing value analysis, like I said, and also fuzzy matching. It's a very interesting area of research called fuzzy match of strings. So that might be something that we can tackle there. And of course, we'll talk about R basics. And I'm showing you a screenshot of Data Wrangler using Trifactor. It's available for free. You can download it. It does on a laptop or your machine, but it's a good tool to get accustomed with, and it's a pretty nice tool to have on your repertoire. And of course, this is a screenshot of Google's Open Refine tool. And why do you care? The reason you care is because it's a very exciting field, a lot of innovation, like you see, in a lot of the startups have been founded just recently, and they've been funded very well. There's a lot of these tools, and many companies are realizing that they need to empower people with the right tools so they can get good quality data at the source, so that way they can avoid all the data wrangling or data quality problems downstream. So that's what I wanted to share with all of you guys, and I think I still have about a few minutes for Q&A. So I look forward to seeing you guys May 14th, and of course May 13th, 14th, 15th, and I hope your time was well spent on this webinar, and I'm sure I ran through a lot of it. It's a very dense topic, but when we meet together on May 14th for the session, I guess we'll have a little bit more time to talk a little bit and get into some of the details and do a lot of hands-on exercises. So with that, I have a few questions that came along on the chat when people registered for the webinar. One of the things we talked about is what is the biggest pitfall you've found, right? I think it's a great example, a great question there. And what brings me to say this is a quote by Daniel Boorstin. He is a renowned historian, American historian. He talks about the greatest obstacle to discovery is not ignorance, but it's illusion of knowledge. So that is what stops most people from doing proper analysis, is they think they know it, whereas they only know a part of it. So if you go back to the slide that talks about the data sources, how do you choose your data sources? I think that is important consideration for you. Second is knowing different tools. If the only tool you have is a hammer, everything will look like a nail. So the more variety of tools you're aware of, the more tools you are hands-on with, and the more statistical techniques you're aware of, the more knowledgeable you are. I think your breadth of approach is going to be very varied. So what I'm trying to say is that the more knowledgeable you are in stats, math, hands-on, and a little bit of storytelling, it will make you very effective at some of these aspects of data wrangling and even data science eventually. Another question that came about was how Kafka and Spark can help in data wrangling. Again, that goes back to this new term called fast data. Kafka will help you ingest fast data. Spark will allow you to do streaming data analysis, and all of that data can land in a Cassandra database. So that's like a new stack for all these real-time analytical processes. But where Spark shines is that you can also add to it not only the streaming data, but you can also suck in the data from your relational databases. So now you've got your streaming data. You can join it dynamically in a distributed computer cluster with RDBMS data over your data warehouse, and then now you've got real-time and older data coming together for rich analytics, right? So I think your goal as the data wrangler is to make sure you choose the right format, Avro or what have you, and whatever format you choose will lend itself for analysis. And Spark is excellent. In fact, there's a company called Paxata. Their whole backend infrastructure is running on Spark, and that's one of the prominent companies when it comes to data wrangling. Okay, there's a pure play company. They do purely data wrangling, but their engine is all built on Spark. So something for you to consider there. And if you're looking to learn data munging at scale, industrial scale, these are all companies: Paxata, Tamr, Platform, Alteryx, and Datamir, and Trifacta. All of these have very smart execution engines. So not only when you learn, you actually do the scripting on your local desktop, maybe on a sample, and then you unleash it on a Hadoop cluster, and their smart execution engine will convert it into Pig and Hive. Paxata is a little different. It'll do everything together. Trifacta, for instance, may give a small sample, and then you run it, and they'll do the back end. You don't need to know Pig and Hive or Spark. You just need to know how to use the tool, how to make the script, and let it unleash itself on the files in HDFS, for instance. And then, the question, what's your advice on a roadmap to data science career? I mean, this is a broad topic, but you can start with a little bit of stat background. I've learned a lot from a book called Introduction to Statistical Learning. It's available for free, and if you Google it, if you YouTube it, you get a lot of corresponding videos that go along with it. It'll go through a lot of stat and the math behind the kind of choices you make, and also it has got corresponding exercises in R. So it's a great place to start, is what I would suggest. And of course, there's a website called DataCamp. You can go there, you can get acquainted with R Studio and Python. And in general, I think you've got to be hungry for just grasping a whole bunch of information. And then for Coursera and edX, I've got fantastic courses, but they're a little bit more advanced level. However, I would start, if you're just starting off, I would like you to start with basic math, stat, like variance, what is standard deviation, what is mean, median, what is IQR, what is P statistic, what is T statistics, what is hypothesis testing, stuff with some basics. If you get those under your belt, all these other things will just come along naturally to you. And again, it's a journey. It's not something that you can learn in half an hour or in a 2 months period and start all over again. It'll take you a little time to digest, because it's a very heavy, dense subject. So it'll take you some time, but of course, once you get there, you've just gotten better. And so with that, I'll turn it back to you, and then if you can tell me a little bit about what it is that you've heard from the audience on the chat.
Yeah. Cool. Thanks, Ashwini. It was a great presentation. Actually, I completely agree with many of your comments, and it was my experience too. Like, we spend most of the time in data preparation. That kills all the time. And model building is the cool part, but always most of the time goes into the data preparation. We have some interesting questions here from audience. So let me read out one question. What are your strategies for dealing with large data sets that are too big for a single computer? Does one really need all the data that is being collected, or can one be successful with sampling?
That's great. So that's a good question, actually, and I think that goes to my point is get all the data you can, legally, verifiable, credible, because you never know how the data might be valuable to you, right? So because the cost of storage is so cheap nowadays, that you can put everything in S3 and perhaps in some kind of a secure data source, and which is compliant with whatever data that you're trying to collect, and then you can unleash your data set. So my suggestion is get all the data you can get your hands on, okay? And then you can worry about authenticity, veracity, those kinds of things. But once you've gotten it, like your point is, do I need all of data to make valuable analysis? I might say perhaps yes, okay? Again, depending on your use case, but most of these tools, right, what you would see is that they work very well on a sample. So for instance, I'll take an example of Trifacta. So what Trifacta does is that they take a random sample. You can give me a random sample of certain size, and they'll suck it into your local computer's memory. And then you'll have some wrangling tools. You make your script, and then you unleash it, and the smart execution engine is going to run it in a Pig or a Hive or a Spark, whatever the underlying infrastructure is. and then it'll output the, and again it's an iterative process. So when it comes to data preparation at scale, what you want to do is take a sample and then unleash it. There are other tools such as Paxata, for instance. They'll load the entire data set in a Spark cluster. Okay, so if you got, of course, you've got petabytes and the larger your cluster, the longer it will take you, and perhaps even it might be a little cumbersome there, but Paxata makes it much easier. I'm sure there are other vendors too who are looking at this. So yeah, so I think, so in essence, get all the data you can get your hands on, and open source by itself doesn't solve most of your issues. So some of these things, if you're an engineer, you would love to figure it out yourself. But however, if you're in business, you want to get this done quickly so you can really solve the business need, then look into some commercial aspects of different vendors. And I think there are a lot of innovation happening in this space for doing data preparation at scale, and you'll find tremendous opportunities there for your company to invest in and eventually get benefited from.
Cool. Yeah, that was a great answer. Thanks, Ashwini. That was a very detailed answer. So I think we do have a couple of minutes more, but okay, if people have any other questions, please keep posting. So we do have some more questions, but we can answer them offline as well. But let me take this opportunity to make an announcement about the registration discount that we have for the upcoming Big Data Bootcamp. So as somebody asked in the question, so this workshop is going to be an in-person workshop. It's not a remote. Attendance will not be possible for the workshop for the next weekend. But again, it is more about personal. Personally, you will be helped up by the instructor. So they'll be walking you over all the different exercises. That is the reason it's not possible over the remote. So we do have actually a discount coupon for the upcoming Big Data event that is called webinar. It's all in capital letters, webinar, WEBINAR, and that will give the 10% registration discount for the attendees who have not yet registered for the workshop. So please feel free to go ahead and register for the workshop after this event, and that will be again, this is just an introductory session, and you will be doing several workshops hands-on by the instructors present in the workshops, right? So yeah, thank you, Ashwini. Any other final comments, Ashwini?
Yeah, what I would like to say is, when it comes to Trifacta, I was speaking with one of their product engineers and also their VPs. What they said is that they're looking at, giving not only the sample but also being able to work the entire set. So you'll see that a lot and more companies are going towards larger data sets together in memory, because Spark is making a lot of these things possible. And a quick question that somebody asked me was, how is social media monitoring changing the world? Okay, that's a very interesting topic. What I would like you to do is that go to YouTube and look for a TED Talk by Jennifer Goldbeck. Fantastic talk. People are able to decipher a lot about you merely by your likes. So a lot of that is just unstructured, semi-structured data coming in, and people like these guys are taking all those public data that we are putting out there to look at our pattern of behavior. Somebody's buying bigger bags and a lot of vitamins, and if it's a she, then perhaps maybe they can deduce because of buying pattern they could be pregnant. Okay, and then target market such folks. So political affiliations, gender, religion, intelligence levels, all of that is just coming through Facebook likes. I'm just taking an example here. So a lot of data is out there. We just need to learn how to harness it, curate it, and make valuable decisions to move our businesses forward, and be of course of value to our companies eventually. Maybe start your own company in this space. So I think it's a very rich field. It's a fantastic opportunity for a lot of us who are getting into this space. So definitely watch out for this. There's going to be a lot more innovation, and of course I look forward to seeing many of you guys in the hands-on training class where we'll look into a lot of these aspects, and of course look at a lot of raw data sets and do some really cool things. Right. So thanks, Prasad, for having me there. I appreciate your time and all the audience as well.
So thanks, Ashwini. So I have one quick question, one last question before we close out. I just wanted to answer that. So I run an after-school STEAM program. What concepts would you recommend I include in my program for elementary school kids to prepare them for a future career as a data scientist?
That's fantastic. I think their mathematical bent is going to be very key. I think if you get them involved in math and stats, they can figure out the rest. People start, oh, okay, I should learn Python programming. Well, programming is great to start. Although if you get them involved in mathematical, if I was to look at it myself, because I wasted a lot of my undergraduate time doing things that are not relevant, right? So, but if I look back and say, man, if I had paid attention to my linear algebra class, maybe the matrix multiplication classes, maybe a little bit more, some of those things, it would have been a lot more exciting, right? So what I'm suggesting is that get them in, look at math. I think that will be a great place to start, and of course read books, great storytelling, because at the end of the day, data scientist's job is mostly to tell a story, right, in a very compelling fashion. So I can show you a picture of a Big Mac burger and say, if you eat this, you get so many calories, or I can give you the list of calories. It makes sense for you to look at the picture and deduce your own conclusions. So storytelling, then of course math is going to be a great place to start.
Great. Thanks a lot, Ashwini. I once again appreciate all the presentation. It was very helpful for many attendees, and I hope the same for everyone. So thank you very much once again. Let us close the webinar, and thanks a lot, Ashwini. Thank you everyone for attending the webinar, and we look forward to see you next weekend at the Dallas event. Thank you so much.
Great. All right. Have a good one. Bye.